Okay, so hi everyone. My name is Sam Prosenko, and I'm working in Linara Consumer Group, LCG as an assignee from Texas Instruments. And today at this session, I'd like to talk about new Android bootloader requirements and how those requirements are implemented in upstream U-boot. So, oh, sorry, it's my presenter acting up. So, let me try to go back to, yeah. So, as you all know, Google didn't manage to come up with proper naming for Android Q, like with some particular suite starting with Q letter. So now we have Android 10. So yeah, it was a joke, but anyway, there is a bunch of new requirements for bootloader, and those requirements are mandatory for new devices launching with Android 10, and for all devices that are already present in AOSP, I believe that they can continue using like old requirements for Android 9. So those requirements are checked by VTS, and yeah, the documentation for those requirements just appeared recently, but I noticed that some developments, like some stuff is going on in development trees, and started work ahead, and I'd like to share my insights on implementing those requirements in U-boot. Of course, you can implement the same requirements in any bootloader, like little kernel or I know UEFI, but anyway, we used U-boot on X15 board, so that's why. And this is Android 10 boot flow, at least how I see it. And a little disclosure here, it might be not completely correctly, some steps can be missing. And I just hope that we have some Google engineers present here, and if it's not really correct, they can like correct me and add some stuff on this. But anyway, it's like the presentation is really big. I have like 40 slides and we have only like 30 minutes, so I will skip right down to the end, and because slides are not really hard, it's easy to understand, but I would really like to have some discussion in the end of presentation, like 10 minutes or so, and with the community, vendors and Google if possible, and maybe we can like provide some insights on future of Android boot scheme. So let's start with first step, which I decided to be first step. It's called BCB. And BCB is, sorry, it's acting up again. And BCB actually stands for boot control block. It's actually 2 first kilobytes of MISC partition. It can be some different partition, but anyway, it's usually MISC partition. It's like raw binary data that stores some stuff like reboot reason, some messages that AOSP is sending to recovery. So basically it's like an interface between AOSP and bootloader, right? So you can test if it works like using just reboot commands and providing reboot reason, and then check in bootloader that this reboot reason is actually present in BCB block, right? Also you can do just factory reset in system settings, and it will actually write this reboot reason and stuff to recovery to BCB. What else? So I think it's actually good design, because not all devices have some persistent non-volatile storage like scratchpad. Like on X15 we have one, but we have some errata that not allowing us to use it. So I think the only way for us is to actually use some part of MMC to use like interface between bootloader and AOSP. Let's see how it works. It's actually structured like this. You can find it in AOSP in this project, and file goes like this. And if you want to implement it in your bootloader, you actually need to port it to your bootloader this file. This file is already present in U-boot, and the crucial things here is, I think, reboot reason, which stored in command field, and message to recovery, which stored in recovery field. Okay, so it's like first 2 kilobytes of MISC partition. That's it. And in U-boot, it's implemented using BCB command. Thanks to Eugenio Rosca, who implemented this. and it's really simple. It's like you can load BCB to RAM, then you can work with it like setting some fields, testing some fields, like reading. You can dump the whole BCB and clear and store it back to MMC, to MISC partition, right? We have like some documentation here, and it's implemented here, and you can enable it with this config option. It's as simple as that. And the way we are using it in U-boot for X15 board is like this. It's actually resembles, it's U-boot shell, it resembles bash script. So it's like we are loading BCB, then testing if we have reboot reason boot to bootloader. If so, we are entering fast boot mode and clearing BCB and storing. If it's like the reboot reason is booting to recovery, stored in BCB, then we actually boot to recovery. And we are not clearing BCB because it's like recovery should actually read some stuff from BCB. And otherwise, we just boot to normal AOSP, right? So let's get to next item on my agenda. It's AB, and AB is actually a mechanism for OTA over-the-air updates. And main stuff here is like it's introducing two sets of partitions, like A partitions and B partitions. Like before we had only boot partition, now we have boot underscore A, boot underscore B partitions, and using those two sets of partitions, we can like seamlessly update the system, and if something is not right, we can back up, like fall back to other partition, right? So you can test it. It's also stored in MISC partition after those 2 kilobytes after BCB section, and you can test it like using this bootstl command. And of course, for an AOSP to write the BCB and to write AB information to BCB section to MISC partition, you need to implement boot control HAL in Android. So you can use this command to test it. And some partitions became slotting like this, boot underscore A, boot underscore B, and other ones. And some are not slotted, of course, like this. I won't stop here. It's not the topic of our presentation. So how it's implemented in U-boot and how you can implement it in any bootloaders. It's like three crucial structures. And first one is 4 kilobytes of first kilobytes of MISC partition. It includes, of course, BCB, first 2 kilobytes here, like struct bootloader message field called message, it's BCB. And then after those 2 kilobytes, we have some memory area to store AB stuff. And AB stuff is recommended to use for AB stuff this structure. And actually in this character array, you should store this structure, and you can just cast it to the structure. And in this structure, we actually have this slot information. This is information about AB stuff, right? And it should be like array of 4 elements for this structure, which actually holds AB information. And using this information, you can actually, for each slot, like slot A, slot B, you can actually decide which slot to use to boot your system, right? Like looking at priority and tries remaining at successful boot fields. So this is like this. And if you want to implement it in your bootloader, you should actually like port this file from AOSP. It's the same file that is for BCB. You should port it in your bootloader. It's already present in U-boot, in upstream U-boot. So this is how we actually implement AB selecting mechanism in U-boot. So thanks to Ruslan Trofimenko, who implemented this command, and this command originally was implemented by Google engineers and then ported by Ruslan to upstream U-boot. So now we have this AB select command. It has documentation, it has unit tests in U-boot, and the usage is really simple. You just run this command providing some variable name, and this command will figure out which slot to use to boot your system, and it will store in this variable, and you can use it like this. So you run this AB select, storing the slot name A or B in this variable. You actually load in from eMMC, device number 1 from MISC partition, and then you can use this slot name to actually figure out which partition to boot to RAM and which partition to use to boot the kernel, boot the Android. And also you should actually provide this slot suffix to this kernel CMD line, to kernel parameter. And also you can use it, you should use it, this slot suffix in AVB command, which we will get to right now, actually. So yeah, you'll need this suffix to actually boot your system if your system implements AB, and in Android 10 you must implement AB. So next thing is AVB. It's like verification of partitions. It stands for Android Verified Boot version 2.0, and I won't stop here because it's like really massive topic, but basically it allows you to check if your partitions are signed, they are signed, your partitions, and you can check that all partitions weren't tampered with. So user or some bad guy didn't actually change the content of these partitions, and ViMeta partition actually contains hash for boot partition, and other partitions contains other hashes. It uses hash tree mechanism to actually check it very fast. You can read details about AVB implementation here. It's really massive, but let's get to implementation in U-boot. Basically, in U-boot we have already implemented AVB command. It's implemented by Igor Apanyuk. Thanks to Igor, we can use it. And if you want to implement actually it in your bootloader, which is another bootloader than U-boot, you should actually port the library called libavb from AOSP to your bootloader, and in U-boot it's already ported. And then you can, like using the routines from this library, you can verify that your partitions are correct and nobody tampered with those partitions. And this command avb actually implements that functionality. It uses libavb and verifies that all partitions are fine, and you can proceed to boot the system with green status. So there are several status like green, orange, and red, and it's actually documented very well on Android documentation site. So I won't stop here. And this command avb, it has a lot of subcommands, but I think like major ones is init, initialization of avb, which actually reads the info needed for like initializes libavb using this device and reads some hash from ViMeta, right? And then you can verify all your partitions by avb verify subcommand, providing slot suffix you obtained with ab select command earlier. So this is how it's done, and this is basically, it boils down to this. This is how it's implemented for X15 board in upstream U-boot. So basically, you're initializing avb, then running avb verify command, and if avb verify command returns 0, then everything is fine, and you can decide to boot the system with green status, right? If it's not right, it returns not 0, and you should actually decide what to do next. And this shows us just like failing boot, right? But this is basic implementation. So let's get next. So next thing is one of major thing, I will say. It's Android boot image, and you all know probably what Android boot image is. And this is basically format to keep your binary stuff like kernel, RAM disk, and so on. And before we had like boot image which called legacy. Now this is version 0. This third boot image format, and it had only kernel and RAM disk basically, also some secondary boot stage, but anyway. In Android 9, new boot image version was added, called version 1, right? It just added one field called recovery DTBO for non-AB devices. So for non-AB devices, when you boot in recovery mode, you should apply this vendor DTBO file on top of your DTB file. We won't stop here, but what is interesting that in Android 10, a new field called DTB was added. And now all vendors must actually keep their DTB files in in Android boot image, right? Because before, a lot of vendors used to keep DTB file like appended to kernel image or in some like separate DTB partition. But now you actually should keep all DTB files in this boot image field called DTB, and you can keep it like either concatenated files if you have like more than one file, right, or in some specific Android DTBO format. We will get to this soon, like DTBO format. And also I would like to notice that actually it would be, from my point of view, it would be better to use, fit image from U-boot. But anyway, this is how it looks like, how binary looks like for version 0, version 1, version 2. We see that it's actually backward compatible implementation. And you should actually port this file to your bootloader. It's in C++, but it's actually can be like converted easily to plain C, and it's already present in U-boot, right? So, and I added this boot image command that allows you to, to get the DTB address, and then you can read it to RAM from boot image, and then you can boot your kernel like this bootm command. Everybody knows it. So, and also you should actually pass this kernel parameter to CMD line, which checked with VTS. And another interesting stuff is that I think that boot image version 3 is coming in Android 11, and so actually it separates boot image into two parts, like generic stuff and vendor stuff. And this is actually another thing that I would like to discuss next. You can see this patch which does this. But it's for Android 11. In Android 10, we are using version 2. And next stuff is DTBO. But we don't have much time, so let's just switch quickly. So it's basically Android format for keeping DTBO files. And this very simple. You can keep header, you can keep several payloads, several DTBO files, and just access them by index. You should port this file to your bootloader. It implements structures like this, and using these structures, you can obtain actually some DTBO files from DTBO partition, right? And in U-boot, we already have this gt image command that I implemented some time ago. It basically allows you to get the DTBO from DTBO partition and apply it on top of, like here, apply it on top of DTB file. So you can get DTBO file, apply it on DTB file, then pass it to the kernel as FDT file, right? So, and the next major stuff is dynamic partitions, and it's also very major stuff. I won't stop here for long. And actually, it allows you to interchange the space between partitions. If some system partition has a lot of space and vendor partition doesn't have enough space, it can be rearranged into user space. But the interesting stuff that comes with it is fastboot daemon, which provides you a way to actually flash logical partitions. And right now you can't actually flash system and vendor partitions into physical super partition because bootloader don't know how to do that, and you actually need to boot in recovery mode and enter fastbootd mode, and then you can flash logical partitions. But if you want to flash the whole super partition, the super image is pre-generated, which contains both vendor and system. So, and basically interesting stuff is Google told us in Android 9 that we should actually early mount partitions, system and vendor, via DTBFS stub, and don't use recovery partition, but use RAM disk and mount system as root, and don't actually use RAM disk and pass skipping init RAMFS to kernel CMD line. And in Android 10, basically everything is reversed back. So now we should actually remove this DTBFS step and use recovery partition again, and don't use system as root anymore, and use RAM disk again. So basically it's like in reverse. And I would argue that maybe there were some like ways to provide architecture that would made it more painless, right? But I'm not sure, but that's just my thinking. So this is how partitions are implemented in X15. Logical partitions are stored in super partition, physical partition. As I said, this is how it's implemented. So I won't stop here. And you should actually implement some new fastboot variables, some new fastboot commands like this. So AOSP can figure out that you are actually in fastbootd or in bootloader. And this is how it's implemented in U-boot. And some patches are already meshed, some patches are pending. These patches are pending. We will try to merge this in 2020.01. And this is all from my side, but I would like to stop here for a short time and discuss maybe with vendors and Google and community how can we avoid like further some some pain when implementing new bootloader requirements. And I could help myself, but insert this slide here. So it's like now we have like a lot of boot standards in Android. Like in Android 8, we have one boot procedure. In Android 9, another boot procedure. In Android 10, another boot procedure. And it's quite difficult for vendors to implement it, I would say, because it requires a lot of efforts. And I think there is a better way to do this, which community possesses. It's like it's using fit image, and there is like several items for discussions, but I think we don't have much time right now. So I would like to discuss the one item from here. It's can we somehow make it more painless for vendors to actually implement new bootloader requirements from Android side, right? So I have suggestion. We can actually use U-boot fit image. I'm not completely sure that it's like it will be really doable, because I'm not sure about, for example, security reasons. But I think it would allow us to provide more painless transition to new bootloader schemes. So I would like to hear your thoughts about this, like Google guys, maybe community guys. Is it doable? Is it better? Or maybe it's, yep.
I mean, one of the things I think the kind of whiplash that you've highlighted is been a very painful aspect of kind of the last couple of years, as far as kind of a lack of any sort of long-term Android boot architecture. I know there's initiatives like EBBR that Grant likely has kind of been trying to stir up. For the most part, I think that is kind of excluded Android in the set. I don't know, it's part of it maybe just due to participation, but there hasn't been a lot of syncing there. I'm really not, it's one of those things where I think there should be some way that it could be better. If there's some architecture where, you know, either it was through UEFI or something where the Android UEFI booting could all be done in an app that was generic that, you know, Google could provide, that might be a solution. But yeah, so I think this is really important and a big problem for a lot of vendors, because there's just a lot of work that's spent on this, and nobody buys a phone because of the bootloader. You know, like that's not a part of real value to anybody. And so making the stuff simple, I think, is going to be important.
I had a question about number one. So kind of what's your opinion on boot Android versus open scripting everything? Because I think the problem with scripting is everybody's going to script it slightly differently. If we don't have any reference script upstream, then we won't have a reference boot flow. So adding all these individual commands, they're useful for debugging, but are they actually the right way to implement the canonical boot flow for Android? Kind of with a mind to how it should work going forward, rather than maybe being compatible with all the previous ways that Android booting worked.
So yeah, I actually think after implementing all that boot procedure, I think that implementing the single boot Android command would spare some pain for vendors, because if we can implement it like in a universal way for all vendors, right? So, for example, the way we can choose which boot scheme to use, like Android 9 or Android 10. So I think, yeah, it will be much more better than approach I showed, because as you can saw, it's like it involves a lot of scripting that way that I showed. Like, and it's actually, it's flexible, right? But it's really hard to, you know, to port from vendor to vendor. This is a lot of scripting involved in U-boot. So it will be actually better from performance point of view, I think, and it will be better from like some universal approach, right? So yeah, it would spare some pain of transition if you can like work, like consolidate our vendors and Google efforts working on this command and supporting all boot ways. It will spare a lot of pain for vendors. This is my opinion.
So do you think like Tom and Simon upstream would be open to making boot Android work with, say, Android 11 boot flow, but then leaving the old commands in place for legacy versions, rather than having one mega command that does all these different possible boot flows? Because I think that has drawbacks too, makes the code kind of complicated.
Yeah, exactly. That's why I think that we should have both ways, like smaller commands, because it's convenient for development reasons and debugging reasons, as you say, and but we also should have this boot Android command for vendors who just want to you know, spend as less effort as possible. So yeah, I think it's and I think that probably we can convince Tom to actually apply this. Yeah, because yeah, we have a lot of reasoning here. So maybe someone thinks, maybe someone has some thoughts about fit image, and maybe we can like somehow, you know, convince Google to like adopt this fit image stuff, because from my point of view, it will spare us the necessity to you know, provide new and new image formats and provide new and new partitions.
So I'm Steve Muckle. I'm the guy responsible for vendor boot, so you can blame me for that come Android 11. And yeah, so I'm not familiar with the fit image, so I'll have to take a look at it and see, you know, if that's something that could meet our needs. I mean, vendor boot, I think it was tough, you know, when the early boot image formats were written, you know, it was hard to envision, of course, that we were going to want to split that and factor all the vendor bits out of boot image. So I don't know if that's something that fit image can accommodate. But yeah, I promise to have a look. So.
Yeah, thanks. So yeah, from my point of view, I think yeah, fit image could do that, could do the same thing, because it provides you a way basically to incorporate like a lot of binary images and store configurations for each image. You can reference any image by some actually string, not indexed by string. It's actually a much more convenient way, and it also has some, I think, security cons for fit image, because it has sign-in on it. And I know that fit image is not implemented probably in bootloaders like UEFI or in a little kernel, right? But it's implemented in U-boot. But probably it would be better to implement its support in other bootloaders. And also, I think it's really good stuff to separate vendor stuff and you know, generic stuff in boot image, because it provides us a way to control it better, right? But I think it's possible using fit image too. So we can just store different images inside fit image, and this like spares us of necessity to keep different image formats, and we can store all the stuff in one partition, which would be like more convenient, more simple way, right? So.
Yeah, I don't know about it. I mean, storing all the things in one partition, I mean, the idea of factoring out the vendor bits was ideally that you could just fast boot a GKI boot image, and you wouldn't have to have a single image that was built for a particular device, right? So we'd have to figure out a way, ideally, to have that still be possible with fit image. But yeah, I'll have a look and see if it's something that we could do.
Okay, thanks. So I think that we can work like as community and as Google and vendors, we can work together and like have more discussion on this stuff and like make it better for everyone. So if anyone has any points or any questions. Okay, thank you.